writing formulas for oxyacids. So suppose I had sulfuric acid. First of all, I would know that sulfuric acid is an oxyacid because there's no hydro in the front. You have to figure out which polyatomic ion you have. And because there's an ick here, you know that this is SO4, sulfate, SO4, 2 minus. Knowing that, now you can do the crisscross between H and sulfate. Just like this. Make sure you actually put a bracket around your polyatomic ion just so that you remember not to touch the subscripts at the bottom. And you have H2, SO4. Don't forget to put your AQ. Now, if you had hydrosulfuric acid, you know that's a binary acid, and you'd actually just be doing a crisscross between S and H. But here we have sulfuric acid. You might have sulfuric acid. In that case, you need to remember that this per part means 1 above the 8. So you probably had per sulfate here. So per sulfate must be SO5 minus 2. And so if you do the crisscross, just as we saw in the previous video, SO5 minus 2, you get H2SO5. AQ. Just like that. You might have carbonic acid. So if you have carbonic acid, you begin to realize it's not binary because there's no hydro in the front. Because you see ick at the end, it was probably an 8 here, so this was carbonate. And you know that carbonate is CO3 minus 2. So when you do the crisscross with H and carbonate, you get H2 CO3, and don't forget that AQ. We'll do one more example together. We'll focus on the bromate family. So you might have HBrO3 AQ. You might have HBrO2 AQ. You might have HBrO AQ. Let's just add HBrO4 AQ. So here we have the bromate family. You need to recognize that you have BrO3, that's bromate. So that's usually the first one that we'd name. Since we have bromate, we'd replace the ending by ic, so this becomes bromic acid. The one above the O3 is the per-bromate ion. So you would call this per-bromic acid. The one below the O3 is the ite ion, the bromite. So this would become bromous acid because you replace the ite ending, so it was bromite, you replace it by us when it's the acid. And finally here we had hypobromite. Since it ends in ite, you replace it by us and then add the word acid. So if you go back and review your derived polyatomic ion rules and combine these with the acid naming rules, then you should have no problem completing the rest of these problems here and other problems in the practice packages. It will require some practice, especially to identify when you have a binary acid compared to an oxyacid. Remember, the main giveaway is that for a when you're looking at the formula, the oxyacid has a polyatomic ion with oxygen, whereas the binary acid just has two elements, H and some nonmetal, for example, F, and there's always AQ for all of them. If you're looking at the name, though, the main giveaway is that you don't have the hydro in the front, not the hypo, but the hydro in the front. If there's a hydro, it's a binary acid. If there's no hydro, then you know you're dealing with an oxyacid. And that's particularly important, especially when you're comparing acids like bromic acid versus hydrobromic acid. You need to know that here you're dealing with H and bromine, whereas here you're dealing with H and bromate.